There you go. So, hi there. How are you today? So, my name is Filippo Santoni de Sio. I'm a colleague of Jeroen van den Hoven at the section Philosophy of TU Delft. And I will tell you something about this project I've been running for 2 years, and in particular on the philosophical part of it, the definition of meaningful human control. And in this work, of course, I've started working on that with Jeroen, and then I've been working mainly with Giulio Mecacci, who is sitting somewhere in the room, and he is partially responsible, for better or for worse, of what you will be hearing now. By working with Jeroen, I've learned something very important about responsible innovation and value-sensitive design. This is one of my favorite quotes from Jeroen and other colleagues in Delft. When I moved to Delft, that was something that really struck me. But what, as a philosopher, we talk innovations, define innovation. If you talk to engineers, innovation sounds like do new stuff, new functionalities, new gadgets, something that works better. But then Jeroen and colleagues say, hey, but this is a very limited conception of innovation. Like real innovation is when you can break a trade-off between values. You want to achieve something, you want to achieve something else. Current technology doesn't you allow to achieve both of these things. You make an innovative design that allows you to achieve both of the things you want to achieve, right? This is real innovation according to a certain view of responsible innovation. And in order to do that, I will not repeat that. You need a lot of a different approach to technology. You need more interdisciplinarity, more of a design perspective, also in philosophy. You need to take social science and empirical studies very seriously. You need to reflect on technical and institutional design at the same time. So a lot of challenges that AiTech project, as I understand it, will try to take on. And also you need to have what at our faculty TBM we call comprehensive engineering. So I think our faculty is a good example of a first attempt of realizing an institutional place where this can happen, because under the same roof you have complex system engineers, you have people studying the human side of systems, multi-actor systems, and you have people like us studying the human side of it, the value side of it, economic value, philosophical value, ethical values, safety and security, and so on and so forth. Now, indeed, a meaningful human control idea came from a philosophical point of view from this idea of breaking the trade-off. Like if you talk to people in different areas about autonomous technology, you will hear this sort of a dichotomic answer. Hey, sorry, if you want to go for autonomy, then, and for efficient innovation, apology, but incidents will happen, shit will happen, and this thing of human responsibility, human accountability is kind of overrated, right? Why do we want responsibility? Let's just go the way for efficiency, innovation. And on the other hand, you have very conservative people, technophobic people who say, no, we don't want any of that because we want to stick to all possible safety and human accountability. So the whole idea of meaningful human control is, again, hey, why should we choose? Why can't we try to redesign the whole process of design and regulation of autonomous technology in such a way that we can achieve both a maximum level of safety and accountability and all the efficiency and innovation we want to achieve. So that's the basic push of the project. And again, this is the project we are in. It's an MBO project. We have partners, and we have engineering, traffic engineering, social psychology, behavioral psychology, and philosophy working together. So again, this is sort of a attempt to realize this idea of responsible innovation. Of course, this is a background of the specific case study, namely automated driving systems, and this is the setup of the project. So basically, we are moving away from the robot dilemma to some definition of meaningful human control. We have these 3 disciplines, we have 3 use cases, and we are trying to answer these 3 related questions. And in particular, Giulio and I are busy with a philosophical conceptualization of meaningful human control. But as Jeroen said, this is not our term. The term was coined in the political debate on autonomous weapons systems. And in particular, the NGO Article 36 came up with this notion, and everybody was super happy about that. So that was a very interesting political phenomenon when a certain term magically started attracting consensus around it. And then the problem was, as a philosophers, that while you're reading the definition of these terms, everybody's going their own way. And I've been to some of this discussion, as you mentioned, and at some point we were like, look, we need to find a philosophical definition if we want this concept to work. And we're like, shh, no, don't do that, otherwise we will stop agreeing. Right? There is this interesting thing. I've talked to people involved in this process that they don't want to define the term because the fuzziness of the term is what allows for disagreement. But as philosophers and designers, we do need and we do want this clarity and this possibility of translating the concept into design requirements. So maybe, I'm not an expert of the diplomacy and politics about autonomous weapon systems per se, so maybe it's a good idea to keep it vague there, but it is not here in Delft and in other technical universities. So the story of meaningful human control is at some point people were very concerned about the possibility of having fully autonomous weapon systems for the reasons that you mentioned, and this is a definition among many others of what an autonomous weapon system is, which is already quite a controversial thing, as you can imagine. And basically the two main concerns with autonomous weapon systems were unpredictability. What if, as Jeroen said, at some point a target is identified as relevant, and it was not. It was just some, AI messing up, as sometimes it does. And on the other hand, what if that accident happens, people are killed, civilians are killed, and there's no way to reconstruct the chain of accountability, which in the military and political domain is super important, as you can imagine. So there was this idea of meaningful human control, and this was the general definition of it. So humans, not computers and their algorithms, should remain ultimately responsible, and this is, of course, the difficult part, for potentially lethal operations, a critical function that Inal mentioned in the beginning. And this is in a nutshell the result of many years of reflections that Jeroen and I had in this paper of 2018. So at some point Jeroen and I thought, look, we have this experience of working on free will and moral responsibility for many years. There's a lot of theories out there, and some of these theories specifically focus on the conception of control at the level of individual human being. In order to be responsible for your action, you need to be in control of your action, right? And so we try to use a specific theory in that field. I will not enter into that at this time of the morning. It would not be a good idea. But we took some of the criteria from that specific theory of Fischer-Ravezza, and we translated it into criteria, expanded and translated that into criteria that could work for the control, the meaningful human control, which grounds responsibility over autonomous systems. And these are the two conditions we came out with, tracking and tracing, which, mind you, this is a disclaimer, they do not necessarily mean what you think they mean in engineering or your discipline, so it's a specific meaning of that. And by tracking, we mean that the system conceived of as human operators, operating device, infrastructure, so the social technical system should be able to, should be designed in such a way to be able to co-vary its behavior with the relevant reasons of the relevant human agents in the network of the systems. This is a tracking condition. I will get back to that. And the trusting condition is supposed to cope with the accountability problem. We want, at the same time, that in any of these social technical systems, by design, there is at least one human agent which at the same time can appreciate the technical capabilities of the system, so has some sort of a reasonable understanding and expectations towards the behavior of the system, while at the same time also appreciating her own moral responsibility for that. So we want to prevent the responsibility gap, where on the one hand you have engineers who understand everything about the system, but they don't consider themselves responsible because they have shifted the responsibility to the users. While at the same time you have the users who do think they know that they are responsible for that, but at the same time they can't appreciate the technology enough as to really be responsible, as in satisfying the conditions of capacity control on the system itself. And indeed, you don't need to go to very futuristic autonomous weapon systems to realize that with very low levels of autonomy, you can really have already big problems of meaningful human control. And the Tesla accidents, this is a stupid accident, but as you know, there have been way more tragic accidents with fatalities involving Tesla autopilot, just as one example. And there the problem was clearly this, that was a big moral responsibility gap. From a legal point of view, that was settled. The driver was responsible. Idiot, you should have had your hands on the wheel. Case closed. But from a moral point of view, this is disturbing because this driver hadn't received any training, was not fully aware. Of course, he has signed a lot of terms and conditions, as we all do with all these technical systems, but it's really dubious whether he had some deep moral responsibility in the sense of knowledge, control, etc., that Jeroen mentioned. So basically, we started to realize that also in the driving systems, there is a big problem of definition of human control. And this is a standard definition of autonomy. And what is a bit concerning about this a set of definitions about autonomy is that it seems to suggest that the more you are on this side, the more control you have. And the more you are on that side, the less control you have. Which is sort of a heuristic that does not necessarily work, because Tesla is here too, and this seems to suggest that the driver is in total control just because he has his hands, he's supposed to have his hands on the wheel. But as we see, this is not the case. So there could be a mismatch between our definition of control from a technical sense, as Inad said, and our definition of meaningful human control, the kind of control that grounds moral responsibility. And so indeed, this is sort of a traditional control as we non-engineers understand the engineering notion of control, right? In as far as there is a responsiveness of the system to the action or behavior to a designating agent, human or not, there is control. But this is not meaningful human control. Why? Because this applies very well to old-style dumb systems, but does not apply to everyday systems. This is a metaphor, a variation of the horse metaphor of Frank Flemish, in which you say, okay, is it clear who is supposed to do what in order to achieve what from a train? But here, who's in control of this specific horse here? Is the horse itself, because it's smart, intelligent, autonomous? Is the specific driver of the horse? Is the audience around? Is the person in the audience who has trained the horse? And so on and so forth. Is the interaction of all of these elements? How do we define control there? This is the challenge of meaningful human control. And our answer is, in a nutshell, that our tentative answer, which is a very broad framework, which should be implemented in different contexts with different tools, etc. The general idea is, by using this tracking and tracing condition, the system is under meaningful human control to the extent that it responds not to the action, but to the reasons. So a more abstract level, not the behavior, but the reasons behind the behavior, the values, the norms, the intentions, of who some designating human agents, which may be the user, the controllers, could be the designers, could be, so we're also broadening the scope of the potential agents who could be deemed as in meaningful human control of a specific system. And at the same time, there is at least, this is a tracing condition, at least one human agent who can be legitimately called to answer for the wrong behavior of the system. So we should design this example in such a way that by design, we can reliably and demonstrably show that the relevant elements of the system are responding by design to the relevant reasons, values of the relevant agents. So it's a lot of work, right? That's why we're here. And at the same time, that there is at least one person there, be that guy in the audience, be that the guy here, the trainer of the horse, the organizer of the fair, whoever it is, who has entrusted with a responsibility, not only in the legal sense, which is the current solution now. Let's just decide that you're responsible, you pay. And we discussed it in the past week. This is sort of a legal scapegoating, right? We don't want just to decide a priori that someone will pay. This wouldn't be fair. So we want to entrust people with real responsibility, as in the capacity and the awareness to realize these responsibility conditions by design. So in a nutshell, this is just closing our talk with some specific implications of it. This means that we need to really have a broader conception of the different technical and human components in a system, moving to a broader understanding of what the system is, not just a device, but the institutional system around it, the network of people around it, etc. Identify the social players and the values that we may want or not want, all in advance by design, designed to realize this interactiveness and interaction between human and robot, and David will say more about it, I guess, and training humans, also lay people, to realize this control condition, identifying, this is more the psychological part of it, identifying the necessary human capacities for and relevant knowledge of a given control task. You name it, what else? Creating effective mechanism of public accountability. So this is just, I'm going back to how the story started this morning with Inald. This is a very multidisciplinary enterprise, but we hope that with this notion, this specific interpretation of the notion of meaningful human control, we may have contributed to have some steps forwards in this complex task. Thank you.
Thank you, Filippo, Santoni de Sio, and Jeroen van der Hoven. We have a few minutes for burning questions. Who would like to give a reaction or ask a question to one of the two former speakers? Here you go. Can you please speak into the mic?
Great presentations. Is this working?
Yep.
Is there an example where meaningful human control has already been applied to a large degree? So many of the aspects you're mentioning are already on the table and have been discussed.
You mean as applied to some autonomous technology?
Some autonomous system that's already out in the society.
That's a very good question. We as philosophers, we tend to focus on things that do not work. So it would be nice to have a positive example of that. Let me think about it.
No. No.
Yeah, I cannot come up with one specific example. I can give you the sort of the idea. I mean, for instance, if you have something working in a very controlled environment, take automated driving systems.
Right.
For instance, I guess if you take, there is this project in the Netherlands, the WePod project. And indeed, it's a very gradual attempt to get to autonomous driving, but step by step. And so, for instance, you have this shuttle who is unmanned, but there is a remote controller sitting in a control room. And this is where, for instance, you have this idea of combining a professional expertise as opposed to a layperson on board, sitting without pressure in a control room, operating a system which is moving in a controlled environment, because the environment itself has been designed to not present challenges that the vehicle cannot address. So I guess this is in principle a good idea of a system designed mainly for human control. Of course, if you look at my graph, at our graph, this is very much on the safe side, and possibly not so much on the efficiency innovation side, because still you say, hey, you know, if you talk to enthusiasts about self-driving cars, say, yeah, but we don't need that. We already have trains. If you want to have self-driving cars on tracks, then we better stick to trains. So I do understand that, of course, there's a push to, but the idea is that you should go step by step. Once the thing works, in this control environment, you can, and this is the challenge of the project, you can slightly start introducing variables and testing them. And also the testing part is very important. I didn't mention that. But the testing part is very important too. So that would be a sort of an example to start from a control environment by design and then removing obstacles.
Well, that's kind of where we are, right? We have robots in all the controlled environments, and we want them to be in society right now. So this is when we need to really think about these things.
Indeed.
Right behind you, one last question. Jeroen and Filippo will be around for part of the day, so but we can take that question, please.
Thank you. I would like to ask a question about, okay, it's nice to have a meaningful human control, but what if you cannot expect a meaningful human control? I'm thinking here about, for example, nursing homes where people with dementia are supposed to be empowered and supported with autonomous systems, semi-autonomous systems. What then? How does your framework work in that kind of setting?
So you're assuming that it is in this setting meaningful human control will not be possible?
Well, the person from the mild cognitive impairment cannot fulfill the criteria of a...
No, not that person, but a part of the theory is exactly that you may shift the meaningful human control to other persons. Like you may have controllers somewhere sitting, you may have the design of the house be, or the device be as such as to not allow for things that could be, you know, detrimental to the privacy, well-being of the person. So my first reaction would be maybe meaningful human control is possible. We need to study that.
Okay.
Maybe, of course, that's a great example, because if you focus only on the obvious controller, maybe you cannot achieve it.
Yeah.
But maybe there's some other way. And the other answer is, unfortunately, if at some point it really turns out that technology does not allow for meaningful human control in a critical setting, we may decide not to go for it.
Okay, thank you.
Yeah. Thank you very much. Both of the speakers, let's thank them again.